Now we're going to have Rob Zinkov from, you can see, unaffiliated. He's going to talk about Infer.py, basically using Python. Well, you've changed the title.
Did I? Oh. Oh, no, that's you're reading the wrong one. I shortened the title.
Many talks. Okay, probabilistic programming from Python.
Exactly. All right. So anyway, this talk's going to be about doing probabilistic programming in Python, and in particular, kind of why you want to, kind of how you would actually do it in Python, and also largely why you want to even be doing kind of probabilistic programming at all. Luckily, Olivier has kind of given us all a bit of a keynote to motivate a lot, which is really helpful. But I'll try to add a little bit of my own take on why you should care about probabilistic programming, as someone who kind of does it a little bit more day in, day out. So just to kind of be clear, Infer.py is a wrapper around Microsoft's Infer.net probabilistic programming library. This is a library for representing probabilistic programs and then running inference over them. So the goal of talk isn't necessarily to get you completely proficient in using Infer.net or using Infer.py. It's kind of getting comfortable with why you would want to use a library like this and kind of taking that goal and kind of pushing forward toward making Infer.py or something like it, something that we all really want to use. So as kind of a caveat, this code is very alpha. It's very much more proof of concept than anything else. It's more just showing the idea that we can do this. We can grab this library and start actually making these very effective, very useful programs immediately. Also, it wraps the .NET library, so it's very janky, which should go without saying. So, but beyond going, what is probabilistic programming, which I think was answered pretty well in the previous one, I really want to talk about why, because I think sometimes people talk about kind of these generative stories, but I don't think they really capture what's the real value with probabilistic programming. And it's the value that your models are programs. You don't go out and find a method. You don't go and look into a manual for a model. You think about how you think your data was generated, and you write a program to describe it. You don't pick out a class. You don't do it. You get to just write a program to do this, and I mean, you don't have to do this. You could write your models by hand, which is what, in theory, we've all been doing. Whenever you have a model with a good amount of structure and a good amount going on, you could write your model by hand. But then you also have to write your inference method by hand. And it'll have bugs, because anytime you write an inference method, whether it be doing a message passing or a Markov chain Monte Carlo, you'll have bugs, and they'll be hard to diagnose. The real uglier truth, though, is people rarely even get that far. People don't write their own models. It's just too much of a pain. You find software that implements the model that looks closest to this problem you have and kind of just run with it. And because most of these models are supposed to be robust, that's still kind of okay. But it's the wrong way to think. You don't want to be coding to the method. You want to be coding to your model, and then the method should come afterward, because that's how you actually get the better results, the better accuracy. It's by capturing your insights in your problem and turning them into a model. So what kind of models am I talking about? I really mean the kind of models with a lot of structure and a lot of kind of interactions. So there's a particular model of this of you're trying to predict how well Alice, Bob, and Sid are at a game. And in this situation, you could model this in terms of this ordered logic and do all this fancy statistics to get it through. Or you can say, I know their skills are roughly with a particular Gaussian, and then I know that I saw that Alice performed better than Bob, Bob performed better than Sid, and Alice also performed better than Sid, and then just say, algorithm, you tell me how skilled they are in roughly this amount of code and roughly this style of code. And the important thing is that complex model, very easy to specify in this way. This is a very easy and intuitive way. And this isn't really a way that requires that much statistics to do. And that's kind of the role of Infer.net. It's to let you write your models in the kind of way you think about them, in the way you think about how your data comes to be. There's these latent variables that you observed, and then your data kind of grows to reflect them. Now, these aren't just academic exercises. When you can start modeling the data creation process and where it involves multiple heterogeneous pieces of data interacting, this is basically as the most general tool you can get. This should model nearly all this should be able to capture nearly all statistical models. And I mean things like recommender systems. Like you can just write a recommender system. Just specify a model there's a certain latent characteristics that make a user what they are, a certain latent characteristic that makes an item what they are, and then they interact, and that interaction with some probability creates a purchase. That's essentially all this model says. But you don't have to write all.
Can you zoom in some? It's hard to see.
Oh, of course. But this is all you have to write. Now, given this code is a bit dense, but usually, as far as most people are concerned, implementing a recommendation engine is like a project at companies that takes months. It isn't just a thing where you write a paragraph of code and kind of go for it. Likewise, for predicting social network connections, it's not something that people can typically conceive of as something where you just write your theory of why people connect to each other based on latent variables that represent their personalities. No, you have to make the statistical model, and you have to think about, these matrix interactions, and then you need this like matrix completion library, and you lose track. You get mired in the inference method, and you lose sight of the actual model that your data represents, which is usually fairly succinct. Now, I haven't yet converted these examples to work in Infer.py, but there's nothing stopping me. It's really just been just a lack of time. But that's the whole point with Infer.py, to take those models and run them from Python, which is what we all love to use, versus .NET and C#. Not that I'm judging. Anyway, so the basic implementation of Infer.py is I took Python.NET and I then used it to call into the Infer.NET DLLs from Mono, and I tried to write some kind of sugaring to make it look the example code look a little bit more Pythonic, and that was it. It's very small. I haven't really written much, and it certainly should be. It certainly should still do more. As far as why I did Python.NET and .IronPython, like IronPython is a losing game. You're on alien territory. None of the ecosystem works. You lose all of it. You lose NumPy, you lose SciPy, you lose Matplotlib, you lose IPython. People say you can use IPython from IronPython. I have not been able to get it to work. You lose the entire ecosystem. No C extensions. You're not. IronPython is really, I think, for people who do .NET and occasionally want to write some Python. It's not for people who actually write Python code. So really the ideal circumstance would be something in a certain sense, which is you stay in your ecosystem and then you stay in your ecosystem and then you call out to .NET. And this becomes the distinction between commuting to work and sleeping under your desk. You have a much more pleasant environment and much more pleasant time working. So you do want to do Pythonette. Now, I'll show how these programs end up looking. Now, to keep it simple, I'm basically going to show you how to do basically the simplest probabilistic program, which is estimating the mean and variance of a normal variable. So, how does this work from Infer.py? So first, we have to define the model. Due to the nastiness of Infernet, you have to explicitly create your new variables, each one by one. So you have to create one for the length of your data, then one to kind of describe all the different values your data will take on for the range. Then you create your data. You put a prior on the mean and precision of the value, and then basically what you then say is each of the values that I observe is basically some sample from this underlying prior. So by default, we're just assuming that it's zero-centered with a fairly wide variance. And then we're just going to iterate through and thus say that everything's kind of a deviation off of that. Then we put in our data. In this example, I basically just said all of our data comes from a normal distribution centered at 42 with a standard variance. I then say, this is the size of the data I've observed. This is the actual x I observed. So contrasting this is what we observe for this random variable, and this is in a certain sense its prior, just to kind of put it in Bayesian terms. Now, that's it. Beyond that, you initialize an inference engine, and you infer the random variables you care about. Not to conflate these, this mean and this mean are not the same value. I'm just overriding it to make it easier on myself. But the important thing to note is, with Infer.net, you get multiple choices for inference backend. So if you know something about your model that a particular inference strategy will be more effective, you can just put that in there. All right. So what does this actually look like when it's run? All right. I'm gonna assume people want this to make a little larger. So here's what it essentially looks like. There's some extra wrapper code, which is I just needed to infer some wrappers. Note, because I'm in Pythonnet, I get to use matplotlib. Basically, all the code I described, and then what I do is I'm just going to plot both what I had set the prior to before and what the true value was set in advance. So, demo gods be willing. We'll import it. We will run it. And there we go. So the purple, can everyone see this? All right. The purple is the actual true distribution, while the blue is our estimate. As you can see, we a touch underestimated the variance, but we basically nailed the mean. And it's really just that simple. So you just write your model, you write your inference, you pull out the variables you care about. All right. So what's kind of the step? What's the step beyond this? That program was still kind of ugly and not very Pythonic. This is kind of a starting step. I think Infer.py really does need to look nicer, but the hard part is done now. We're firmly in Python land. We have all our tools available, and we can start wrapping it to make it look the way a Python probabilistic program should look, as by whatever values we feel. But there's also a question of just why not something else? Like, isn't like having this dependency on a .NET library kind of a pain and kind of hard to manage? Yeah. So we have PyMC, but PyMC is it's MC in the name. It's very much about Markov chain Monte Carlo. So it doesn't get. PyMC could be this probabilistic programming language that we really need. We don't necessarily need Infer.py. The trouble is, for really efficient inference, you need to move beyond just MCMC. You need to be able to have things like message passing algorithms or approximate message passing algorithms like expectation propagation. Assuming PyMC does not grow to fill that need, I think there is still a need for a library with a few less dependencies that is just as efficient. Anyway, check out the code. It's already online. It basically works as you saw. The examples work, but I definitely want the examples to look more beautiful. These are further resources on what probabilistic programming is, what Infer.net is, and PyMC if you haven't heard of it. Questions?
Do you have any trouble running the .NET, like the Infer.net, using Mono? I'm thinking.
I had no issue. I ran this out of Mono. So I got it working with. So the question was, have I had issues running Infer.net from Mono? The answer is, I have not had issues doing that. Basically, I use Mono 2.10, and it seemed to work just fine for me.
What is the state of Infer.net?
So the question was, what is the state of Infer.net? The state of Infer.net is that it is actively being developed. So it should continue to keep going along. Oh, I forgot. One of the other issues with Infer.py is because you use Infer.net, it's bound to the restrictions of the Microsoft research license, which basically says no commercial use, which is kind of a deal breaker for nearly everybody. So yeah, thought I'd just mention that.
So mentioning that PyMC is growing a fair amount these days, they have some sort of abstract expression tree behind them, and PyMC 3. What stops, is the theory that you're presenting here, is that amenable to their abstraction? Is it possible to add this knowledge into them, or no? Why fork? Why not contribute?
The question was, does PyMC support what is needed for something like Infer.py to just be within PyMC? Is that a fair characterization? So the issue is, it might be, but I'm very considerate that like projects don't want to kind of have scope creep, and I think that's actually like a discussion that needs to be kind of had first and foremost, of whether it's appropriate to increase the scope of PyMC or not. I have no personal opposition to less projects and less things just doing basically the same thing. And this is not a fork. I want to make this clear. There's no code sharing between this project and PyMC. So.
Basically the solution for the variance issue, what's kind of the reasoning behind that, and would it get better? I didn't really understand kind of why there was a difference.
The question was, why did my estimator not perform better?
Yeah.
So I haven't fully tried to debug the program. Two things could be going on. One, I may have just misspecified how I was passing in the variance, because you saw I was kind of freely moving between variance and precision. I was kind of hoping by setting variance to 1, I kind of remove the risk of convoluting standard deviation variance or precision, because they'll all be the same value. But it could be that. I could just need more data.
Yeah, you only drew like 100 points. Right?
I only drew 100.
Okay.
Yeah.
What kind of
the question was, what distributions Infer.net support? It supports gamma, supports Dirichlet, supports multinomial, supports Bernoulli, supports truncated. No, it doesn't support truncated version. It has quite a few, actually. Also, in addition to these, I didn't highlight this in the examples, it also supports constraints on the variables themselves. So you can say sample a value from this normal, but this normal must be above this value. And that's how you would say approximate a truncated Gaussian or sensor data. I didn't really highlight this in the talk, but it's something else that's also there.
This is the same API.
Yes.
It's actually a follow-up on what you just asked, which is not so much which ones does it support, since you already answered that, but does your API match, or do you support anything that the SciPy.stats distribution? SciPy.stats has a family of distribution objects with a consistent, clear API and a parent base class that kind of provides all of that. If you supported that API, basically anyone who implements a distribution against the SciPy.stats distribution object data would be automatically supported, or did you implement that separately, kind of on your own?
So the question was, how much did I try to implement the SciPy stats distributions? The answer was, I did not try to make them congruent with each other. I think that's actually like something that I really should do. My sense is that there's overlap, that neither library is a strict superset of the other. But even given that, I think the library could still be useful even if it just implemented a subset of the SciPy stats distributions with the SciPy stats APIs, which I think is the important thing, which is this going forward, this thing really should look more and more like should look more and more like SciPy and less like Infer.net. So,
You had a question.
Yeah, I had a short question. Is the Infer.net project itself well documented? And so
the Infer.net project is reasonably documented. There are examples, and there's a manual. It's not authoritative. There's also forums, but some of the code is like forum code, not the most ideal. In a certain sense, it is the only documentation because I've put almost next to none into Infer.py. But Infer.net is reasonably documented. All right.
Yeah.
Well, thank you.
Thanks.